Today we're going to be testing out some DC fuses, and these are very common for 12-volt systems. And these are one of the most crucial parts of a system. These can prevent a fire. But how well do they work? Some of these are $15. Can you depend on these or not? And for today's video, we're going to check out these terminal fuses that mount directly to the battery, standard A and L fuses, and small T-class fuses. Now the first test I did for the last few days straight was running all of these at 90 to 95% of their rated capacity, and then using my heat camera to see how hot they get. And the reason I'm measuring their temperature is because the hotter that they get, the more resistance that they will have, and that will change the voltage drop, and that can change the voltage readings of your devices that you connect to them, whether it's an inverter or a solar charge controller. So the cooler they run, the better they work. Also, because these are temperature dependent switches, they disconnect when they get really hot in the middle. The tripping characteristics are dependent on the temperature as well. So if the temperature is really high, it can trip before it's supposed to. And that can be dependent on how you wire them up, especially the size of lug and how they fit. If you use the improper size lug or fuse holder, it can trip early because it's overheating. This is also true for DC rated circuit breakers. So first, let's talk about these fuses. And all of these are rated for 150 amps. We have a mega fuse, an AMG, and a Bojack, and they're about the same price. But they run at different temperatures. And for my test, I ran these at 142.5 amps, which is 95% of their rated capacity. And the highest temperature for the mega was 150 degrees Fahrenheit. And for the AMG, it was 139. And for the Bojack, it was 180 degrees Fahrenheit. And technically, these are all within spec. But which one do you think I would choose? I would choose the one that runs cooler, this one, the AMG. Now at the end of this video, we're going to test these to failure, so stay tuned. Now let's talk about the terminal fuses. Now these are designed to be mounted on a battery directly, straight to the terminal. And then you add the fuse on top like this, and then you add a cable with the properly sized lug, and then you add the nut on top. This way, if you cause a short circuit, you'll have a fuse right on the battery that can trip. These are fantastic for low quality, cheap Chinese batteries. Just throw this on top and you'll have more peace of mind. Now for all of my testing, all of these ran at different temperatures because they're rated for different current values. And the 80 amp ones were the only ones that failed the test. I ran both of these at 75 amps and they disconnected. And these are made by Bojack, so I would avoid these ones. Now all of these are made by Bojack, but they actually did work. And these are rated for 50 amps, these are rated for 125, and these are rated for 200. Now for the 200 amp model, I ran 190 amps. This one, the max recorded temperature was 263, and this one it was 262. Next, for the 125 amp version, this one ran at 166, and this one ran at 165. Now for the 50 amp version, I put 55 amps through this and it disconnected. That was an accident. For the remaining ones, I ran 45 amps through this. I got 138 degrees. For this one, I ran 45 amps and I got 110 degrees. And for this one, again, 45 amps, but I got 122 degrees. So these were pretty inconsistent. Now these are not made by Bojack and they have an R on them. And all this means is it's made for high current, but guess what? This is pretty much the same as all the others. And the temperature was consistent with the others as well. Now one source online said that the R means that these are designed for motors, like a trolling motor or a winch. But again, it looks the same as everything else and it runs at a consistent temperature. And I ran these ones at 149 amps each. The top one reached 200 degrees Fahrenheit and the bottom one reached 200 degrees Fahrenheit. Now the UL standard for exposed surface areas on breakers and fuses is 185 degrees Fahrenheit, and this entire thing is exposed when it's on the terminal. So with the ones that I tested, the only ones that passed were the 50 amp and the 125 amp. Now most people are not running these at 95% of their rated capacity, so of course they're going to run hot. But safety-wise, if you're using the proper size cable to be able to trip one of these, and you derate it to 60 or 70% of its rated current, none of these will exceed the temperature. But the consistency is pretty bad with some of these, so it's good to check. So get a heat camera and check them yourself. With that said, if I had a 100 amp BMS battery and I was attaching this to the main terminal, I would use 125 amp fuse. And I would try not to exceed 80 amps or so. That way it runs very cool, but you still have safety. Now if I had a 200 amp BMS, I would actually use the 200 amp one and I would derate it a lot. I would plan not to go over about 150 amps. or I would use one of these. This is better. But for small batteries, these are fantastic. These are easy to use, and if you use them properly and you size them properly and use the proper size cable and the lug, these will actually work just fine. But don't buy the 80 amp ones. Now keep in mind the temperature of these is dependent on the cables that you connect to it. And this was with some large cables. If you use small cables, these will heat up. Also, you'll notice in the heat camera photos, there's a hot spot right between the fuse holder and the fuse. And because this is plastic or an insulator and everything else is metal, the heat accumulates right here. If you spend more money on the E10 one, it doesn't have that piece of plastic, and in my testing, this ran 10 degrees cooler. But that's with a single fuse. If you put 2 of them on here and you push them to the limit, it would still get pretty darn hot. Also, these are directional. You have to put them in the right way. Now, these are the cheapest of the cheap. These have all sorts of different labels. Lots of people buy these, but if you want to spend some more money and get something that always works, buy the Blue Sea Systems one. Those are fantastic. Now let's talk about these cheap T-class fuses. I got really excited because I love T-class fuses, but the consistency is kind of all over the place. Now when I bought these, I thought I was getting the same thing, but you'll notice that the one on the left is a little bit different. And these are rated for 150 amps and this one's rated for 100 amps, so I did different tests. So I ran this one at 95 amps and the highest temperature was 138 degrees Fahrenheit. And for the 150 amp ones, I ran 142.5 amps. I got different temperatures. This one ran at 162 degrees Fahrenheit. This one ran at 163, which is good. But the slightly different looking one, which is made by the same company and has the same amperage rating, ran at 135 degrees Fahrenheit. That's fantastic. But why is it so inconsistent? Even though they look different, they literally have the same exact model number, but they're different. So if you can find the one that looks like this, this is the coolest running one. But who knows? I probably need to buy more of these to see if I get consistent results. Now for the next test, we're going to give it an overload situation with my electronic load. So let's go over to the other side of my shop. And this is how I test the fuses. So we have an electronic load on this side, a battery bank over there that's constantly being charged. In between the two, we have large cables that we connect to a fuse or breaker. Next, we input how much current we want to precisely draw from those batteries, and then it goes through these cables. And then we watch it with a heat camera, and then we measure for voltage drop. So let's hook up some stuff and see what happens. So let's start this with a terminal fuse. This is the battery side, so we're going to connect it over here. And this is a 50 amp fuse. Now for the first test, we're going to go 5% over, so 52.5 amps. Oh, this one's holding. 15, 16, 59, 60. All right, we're going to raise the current. This one's not tripping. So now we're going to do 55 amps. 1, 2, 59, 60. And it still did not trip. All right, I have a stopwatch now. This will be much easier. So now we're going to up it to 60 amps. And we start. Oh, there we go. 25 seconds. Now for the next test, 125 amps. And 5% over is 131.25 amps. And it started, and it still didn't trip, so we'll increase it. Now this is 15% over and start. All right, let's just keep this going because the temperature is rising, and yeah, this is 15% over. 153, 160, 175. This is exceeding my continuous load test. And it's not disconnecting, so let's end the test. Now it's 25% over, we're at 170 degrees Fahrenheit, and we will start. Now this is 40% over, 175. Finally! Oh my goodness, we're at 240 degrees. So it took 175 amps to blow this fuse. That is nowhere near consistent with the last one. That's crazy. Now we're gonna do a 125 with the same current rating with the same test. And I tried to find a trip curve online, but I couldn't find it, so we're on our own here. Now with the last test, it was already warm and it took 2 minutes, so let's see what happens. Start the test. The temperature is rising very fast, already at 175, 205. Now the temperature is not rising, so we're gonna end the test. Another 5% gets us up to 181.25 amps. Start the test. Now we're at 260 degrees and it still hasn't blown. So 5% more is 187.5 and start the test. Oh, there we go. It finally tripped. Can you believe that tiny piece of metal actually handled 185 amps? All right, we're gonna test one more, the 200 amp. These temperatures are more than the UL standard. That is scary. Oh, I should have measured the voltage drop. It must have been horrible. All right, 200 amp fuse, here we go. Seems like the larger the fuse, the harder it is to trip and the hotter they get. So you guys don't fall asleep, we're gonna start this one at 220 amps. And it starts. And the voltage drop is pretty high, 191 millivolts. When you run these at 95%, it's around 60 to 70 millivolts. Ooh, and we're at 235. And the temperature is not rising, so let's increase the current. So now 230 amps, start. 278 degrees, and it's not rising, so let's give it more current. 311, and it's not registering anymore. That's the limit of this heat camera. So now we have to increase it again. So here's 260 amps. Now we're getting some voltage drop, 208 millivolts, 209, and the heat camera just hit its limit. Still no disconnect, guys. Now we're at 280 amps. Ooh, it sparked. We finally got an arc. You see that tiny piece of metal? 280 amps to break it. And this thing goes over 300 degrees Fahrenheit. That is pretty scary. I would not buy these. It's unfortunate because these are cheap, but yeah, they're cheap for a reason. You really got to spend more money on the nicer fuses. Now we're going to test a T-class fuse. And these are hard to trip unless you do a lot of current. The main advantage of these is that the maximum breaking capacity is huge. It's like 20,000 to 25,000 amps. So these are great for lithium batteries. And that's because lithium batteries have a low internal resistance and they can quite literally create thousands of amps, especially when you connect them in parallel. So I just spent the last 30 minutes trying to find a data sheet on this and I couldn't find anything. But I did see on the product page, they list that the breaking capacity current is 10,000 amps, which is not that good for a T-class fuse. And these are not cheap. You could just buy an MCCB and it has double the breaking capacity amperage. Now, because we don't have a data sheet, we're shooting in the dark on when it will trip. So we're gonna overload it and see what happens. And these are hard to trip, so we're gonna raise it pretty fast compared to the last one. So 120, start. And the voltage drop is 110 millivolts. We're at 115 degrees Fahrenheit. And the temperature is rising fast, 126 degrees Fahrenheit, so the voltage should drop more, 114 millivolts. All right, it's not tripping. Let's raise the current, 140 amps, and start. Temperature is rising, and so is the voltage drop, 148, 185, 205, and the temperature has peaked, so we're going to increase it, 160 amps. Ooh, 200 millivolts. That's 1/5 of a volt. Temperature is 242 now. And it is still not tripping. Let's raise it one more time. 180 amps, start. 253 millivolts, 290 degrees Fahrenheit. The hotter it gets, the more resistance and the more voltage drop. And now our heat camera is maxed out at 311 degrees Fahrenheit, but we can use the voltage drop as a thermometer, and it is still continuing to rise. Oh, it's rising fast. Look at that. Uh-oh. And now the test is done. It took 180 amps to blow this 100 amp T-class fuse. Whenever I destroy something in the lab, I draw an X on it. And this one's rated for 150 amps. Now for this one, we're gonna do 300 amps and see how fast it blows. And start. The hotter it gets, the more resistance. Uh-oh. There it is, it's rising fast. Disconnect. Wow, that was so cool. So it actually worked. It worked pretty well. Now, if you're running inductive loads like motors, T-class fuses are fantastic because they're really hard to trip. But if you get a lot of current, it will trip very fast. And technically, if we plotted all this data, we could actually make our own trip curve. Now we're gonna test these. Now first is the 150 amp mega fuse. Let's start with 165 amps and see what happens. And start. And look at that voltage drop, 75 millivolts, that's great. And it's rising, but very slowly. All right, we're gonna raise the current, 175 amps. Actually, we can look up a trip curve. This company has to have a data sheet. Oh, wow. Victron has a list of common fuses and their voltage drop. And all of them are between 60 and 135. And the interrupt rating on the T-class fuse, it's like 10,000 to 25,000. On these, it's 1,000 to 2,000. And there's a few models, so you always want to check to make sure what you've got. And here's the curve. It says if you're right at 150 amps, it can take 10,000 seconds. And right here, it says 200% of the rated current, it should trip between 1 and 15 seconds. So let's try that. 300 amps. And I think it's going to trip pretty quick, so I'm going to zoom in. 300 amps start. Woo! And it works! But even the high quality one says it can be between 1 and 15 seconds. So the variance is still high even if you spend more money. These have to be very tight because if it's a loose connection, it will create more heat and will trip early. Whenever you're making connections, you always want to check them every 6 months or so just to ensure that they're tight. Because when it expands and contracts, it will loosen it over time. So this is the AMG 150 amp fuse, and for the continuous draw test, this ran at the lowest temperature. And start. 59, 60. 61, 18, 119, 120, 172, 173. All right, I need the stopwatch. All right, we'll add it up. This thing is not blowing, you guys. 300 amps, no wonder it was running cooler. Look at that, 304. God, I was totally wrong about having it run cooler. Jeez, that worked for the breakers, but not so much for this. All right, it is not tripping, and it's been almost 15 minutes total. So we're gonna do an experiment. We're gonna try to increase the temperature with this towel. Might catch this thing on fire. It is not tripping. I would never use this fuse in a system. Holy cow. The conductor size to carry 300 amps to get this thing to trip is ridiculous. These things are, oh, it's sticky. This is welding cable. You can feel it vibrating. All right, guys, this is not tripping, and it's melting. The heat shrink adhesive is melting. That's how hot this thing is getting. This is super dangerous. All right, we're ending the test. And the metals are changing colors. Yikes, what a terrible fuse. And a mega fuse is only a few dollars more. Well worth the money. This could burn down someone's house. It's still 160 degrees Fahrenheit, yikes. I should have got a temperature reading, oh well. AMG 150 amp, avoid this one like the plague. And now the last one, the Bojack. And we've started the test. Ooh, yikes, that was quick. The Bojack actually worked. That's how it's supposed to work. Now with the cheap DC rated circuit breakers, the one that ran cooler worked better, but not with these. These are different, and some are dangerous. Like this is the same price as most of the others, and it looks good. It looks like a high quality device. But now I am scarred. I'm only gonna buy Mega Fuse, holy cow. And this you can actually get a data sheet for. All of these other ones you can't. So you absolutely get what you pay for. Now we're gonna do some destructive testing. For the final test, we're gonna do a dead short, and this battery does not have overcurrent protection, and it can output 800 amps. And that's important because the breaking capacity of these is 1,000 to 2,000 amps. Anything more and you need a T-class fuse or an MCCB. Also, this is dangerous. Right now I have a 30 kilowatt hour battery bank at 48 volts, and I've destroyed every relay and switch that I've connected to it to do this test. For this one, because it's 12 volt and it's 2-aught gauge, I think we can be fine with this, but we'll see. So first we have a 150 amp terminal fuse. And the switch is off, and it's nice and tight, and the meter is recording. And I'm gonna wear some gloves just in case the switch melts or arcs. All right, here we go. 3, 2, 1. Oh, what? It's not, it wasn't signed in? It wasn't recording? Stupid tool, man. All right, next fuse. Now let's do a 200 amp, so it will be bigger. Now the meter should be recording. 3, 2, 1. And the peak amperage was 176, but this is very quick, and this is a Hall effect sensor, so I'm pretty sure it might have been a little higher, but it couldn't capture it. Next up is 150 amp T-class fuse. In 3, 2, 1. That was neat. I saw the arc. There's sand inside of this to extinguish it. And I can smell it. That stinks. Now the test that everyone's been waiting for. Oh, it does fit. Look at that. So we have the AMG 150, and this did not trip before. But this is the easiest test. I'm pretty sure it will pass. But who knows? 3, 2, 1. Whoa! That was loud. We need to test these all the time. This is so cool. This Vatier has literally 0 overcurrent protection. I was not joking. Now for the final test, this one did not blow with 300 amps. The one we did before was a brand new fuse. So let's see what this does. 300 amp didn't blow. 3, 2, 1. Next up is the Bojack 150 amp. 3, 2, 1. So what did we learn in this video? First off, these fuses are not as consistent as the breakers. Also, if you buy the higher quality ones, they do work well, but the variance is still present. Even with this mega fuse, it can be 1 to 15 seconds for a 2x overload. Next, the variance of the Bojack terminal fuse was all over the place. I still do like these, especially for super cheap batteries, but you need to size them accordingly. Next, the variance for these was pretty high as well, especially the temperature. And the biggest lesson today was any fuse with AMG 150 on it, do not buy. I put 300 amps through this thing and it did not trip. I did it for 15 minutes straight. And then when I did a dead short, it sounded like a gun going off. So this thing was ridiculous. Avoid it. Now, even though I don't like cheap DC breakers, these were very consistent when they tripped. You could count it down, you could see the temperature on the outside, and you knew instantly when these will trip. With all these fuses, it's kind of up in the air. Next, cheap T-class fuses do not have data sheet or trip curves, so I do not like that. But if you spend more money, which these cost a lot more money, the big ones, they do have a data sheet with a trip curve, so buy these instead. But why buy one of these when you can buy an MCCB? And I just bought the largest one ever, 400 amps. And it can go to 500 volts, which is ridiculous. Imagine the arc that this needs to extinguish. That is wild. And compared to the T-class fuse, these are really cheap and you can use them over and over again. And I did more testing with these after my video. No matter how hot I got this thing, the tripping characteristic was very consistent. I like that. And they have so many different sizes. This is a 125 and this is a 100 amp. And as always, use the largest size conductor for each breaker and use the proper size lug for the terminal. If you use quality stuff like this, it will always trip and you don't have to worry about it. But buying the cheapest fuse on Amazon, this is asking for problems. One that actually worked that was really cheap was the Bojack. This one actually worked well. Now, if you want to see what I'm currently recommending for overcurrent protection devices, check out my website. I'll have a link down below. I'll have a link for all of this stuff. And I'll have a warning for this. I want to show you guys exactly which listing I got it from so you know what to avoid. Now for the next video, we're going to do dead short tests of this with a 30 kilowatt hour battery bank. But I'm running into some issues. I was using relays, I was using a large switch, and it was destroying everything. So I think I have a solution, and that's going to be for a future video. But those things might explode. If we put these on that large of a lithium battery, they'll either explode or catch on fire. Or so I think. What if they survive? I don't know. So the next video will be even more fun. I hope you liked this video. It was painful, but we had to do it. Thank you so much for watching, and I will see you in the next one. Bye.